Our last topic for stoichiometry is percent yield. Some definitions you need to know to calculate percent yield is theoretical yield and actual yield. The theoretical yield is the maximum amount of product that can be produced from a given amount of reactant, and this is if you were perfect. So if you did everything right in your lab and you got all the amount of product that you were supposed to, that's your theoretical yield. In contrast, your actual yield is the measured amount of product that was obtained from the reactions. This is what you actually got. This has to be given to you in the word problem. The percent yield is the ratio of the actual yield to the theoretical yield, multiplied by 100. So our formula for percent yield is actual yield divided by theoretical yield times 100. Or in other words, what you found divided by what you should have made times 100. And notice that what you should have made is if you were perfect. Let's look at an example. When 3.2 grams of potassium bromide reacts with excess chlorine gas, 1.7 grams of potassium chloride is produced. What is the percent yield? My first step is to calculate my theoretical yield. So I want to find out how many grams of potassium chloride would I make if I reacted all of my 3.2 grams of potassium bromide. Like all my other stoichiometry problems, I'm going to put the unit on the bottom of the next fraction that I want to have cancel, so I'll put grams of KBr on the bottom. And to find grams, I have to calculate the molar mass. The molar mass of potassium bromide is 119. So there are 119 grams of potassium bromide and 1 mole of potassium bromide. Next, I'm going to use my mole ratio to convert from moles of potassium bromide to moles of potassium chloride. I get my mole ratio for my balanced equation. I have 2 moles of potassium bromide and 2 moles of potassium chloride. Finally, I go back and I find my molar mass of potassium chloride. So I will have 1 mole of potassium chloride on the bottom of my fraction and the molar mass of 75 grams of potassium chloride on the top of my fraction. To solve my problem, I'm going to take 3.2 divided by 119 times 2 divided by 2 times 75, and I get a total of 2.0 grams of KCl. To find my percent yield, I now take my actual yield, which was given to me in the problem, as 1.7 grams of potassium chloride, and I divide that by my theoretical yield, which I just calculated, which is 2 grams of potassium chloride, and I multiply it by 100, and I get 85%. Try this sample problem. Write the question and your work in your notes and show it to Mrs. Benke. If 12 grams of ammonia makes 1.87 grams of hydrogen gas, what is the percent yield? I have given you the balanced chemical equation. First, calculate the theoretical yield. So how many grams of hydrogen gas can you make when you react all 12 grams of ammonia? And then, compare your actual yield to your theoretical yield to find your percent yield.